Hey, what's up guys, welcome back to Eureka, and today we'll be talking about how we can express vectors using their coordinates. Now before we do that, remember that a vector is a quantity that has both a magnitude and a direction. And any vector v can be written as a scalar multiplied by another vector. This is all review from the previous video. Now I'm going to do something similar in this video, but I'm going to incorporate the vectors definition that we had before. So we're going to kind of like link those two definitions together to create something brand new and very useful. Basically, our goal in this video is to replace the idea of this scalar into a magnitude magnitude and this vector by a direction. And you can see it fits nicely with our definition over here, but like how do you actually do it? Now, first of all, let me get some notation out of the way. So a magnitude of a vector is defined, it's denoted by just the letter itself without the arrow, or the vector with the absolute value bars, or the vector with double absolute value bars. Personally, I prefer using the third one, or the first one. I use them interchangeably, but like I don't usually use the second one because I can get mixed up between absolute value and magnitude, even though they're kind of the same thing, but they're not. One's for numbers, one's for vectors. So I differentiate them somehow. Okay, what about the direction? I'm going to replace this direction by another vector. Let's call it u, but instead of u with an arrow on top, I'm going to write u with a little hat on top. I'll explain what this means. This is actually called a unit a unit vector. All unit vectors are denoted by this hat thing. Now, what is a unit vector? A unit vector is just a vector, right? But it has a magnitude of 1, always 1. That's why it's called unit. Now, what about its direction? Now, let me draw my axes. This is my x, that's my y, and my vectors will be centered at the origin, right? This unit vector, for example, u, has a magnitude of 1. This vector, I don't know what vector it is, has magnitude of 1, magnitude of 1, magnitude of 1, and if you draw all of them, you'll see that they lie on that's a bad circle, but it lies on a circle, right? Because a circle is defined by a point and a distance, right? At every single point, that d distance away from the origin. That's what this is. You have an origin, which is the center, and then you have vectors that all of them, they have magnitudes of 1, meaning that they're the same distance from the origin. That's why they create this circle. So whenever I mention a unit vector, you should always think direction. Always, unit vector means direction. Remember, all that we're trying to do is to re-express this equation over here into something more useful that we can actually, solve problems from, because this equation over here basically means you have a vector, you want to make that vector make it longer, but in the same direction, right? We're trying to change it somehow that makes it more useful. I think an example should help. So let's say I want to create a vector v, given that the magnitude of vector v is 5 and it's pointing in this direction, right? Now, how do I represent a direction by a vector? Because this thing right here is a vector, right? We just said it before. A unit vector can mean direction because it has a magnitude of 1. We don't care about its magnitude. As I mentioned here, we don't care about its magnitude. We only care which direction it points. That means that we can get this vector that points in this direction. I don't know what direction it is, but in some northeastern direction. And then we want to scale it up by 5 because this one is a unit vector, right? Which has a length of 1. If we make it 5 times as long, meaning that I can't draw 5 times as long over here, but 1, 2, 3, 4, 5. That will be our new vector. Let me just actually change this to 2. It's way too long. So twice as long, like this. That will be our new vector, because this vector, we said that it needs to point in this direction, which it obviously is, and its magnitude should be 2, which it is because it is twice as long as the unit vector. Let me express this algebraically. So a vector can be expressed by its magnitude multiplied by the unit vector in the direction, so I'll write that by v with a hat. This means, this thing means the unit vector in the direction of v. So let me go over what we covered in this video. We want to re-express this equation somehow. This basically means that you have two vectors, v and u, and they're parallel because they are scalar multiples of each other. I explained in the last video. If you didn't understand, then go to the last video. Now, I did all this work and I arrived at this thing. Now, what is this? This is... Hey, that's way too thick. That's a vector, right? That is still a vector. That is scalar. Vector equals to a scalar times another vector. That's exactly what we wrote up here, but in this case, we express this vector as the vector itself. It's not itself, but it's still v, right? Just a unit vector. And its magnitude. So we only need one vector in this case, whereas this equation needs two vectors. We need v and u. So hopefully I made this clear why this equation holds true. Let me just write it again because it is very important. This is the equation that we take home today. This means that you want to create a vector this vector that is in the same direction as this unit vector, since unit vector means a direction, but you scale that vector in that direction by some amount. That's what it means. You want to create a vector using a unit vector, and then you want to make it longer, and those are equal, those two vectors. Now that we have the formula, a vector v can be written as the product of its magnitude times the unit vector in its direction. How do we actually calculate v hat, the unit vector in its direction? How do we calculate this? Now, let me draw my coordinate axes real big this time, x and y. We want to calculate v hat, which has a magnitude of 1, right? All unit vectors have magnitudes of 1. Remember a few minutes ago I drew this diagram here? Basically means that all unit vectors, as long as they're centered at the origin, they create a circle. Basically, this means that I can create some other unit vectors. I'll create this one and this one. Those two yellow unit vectors are very important. The reason I chose those two is because we actually understand those directions. One is pointing to towards the positive x-axis. That's this vector over here. And then we also have another one pointing towards the positive y-axis. These two are important. They have names. This one is called I hat, and this one is called j hat. Now, our goal is to find v hat, right? Which is this green vector here. This is v hat. Remember that in the last video, I explained how vectors addition work. Suppose that we have those two vectors, and we want to add them. We take the tail of one directed towards the head of the other. That's the resultant vector, or the sum, using the triangle rule. We can do this thing over here as well. We can create, let's say we scale this I hat vector down a little bit, so it becomes this vector. It's the same thing, it just scaled down. And then you add j hat but scale down and move it to the right, you get this vector, right? It's parallel to the j hat vector, meaning that it's a scalar multiple of a j hat vector, meaning that you can scale it down and move it. Vectors, you can move it anywhere you want. This means, let me actually give them names. This red vector is called the vector, it's still a vector, right? It's vector v, sorry, those should be unit vectors. Let me write them, v hat, and this is v hat x direction. This one is v hat, but in the y direction. What is v hat x and v hat y? Notice that we have this angle here, angle theta, right? Using your trigonometry from grade 10 and 9, we know that in a unit circle, which is what we have right now, in a unit circle, the sine of the theta is equal to the opposite side, and the cosine of theta is equal to the adjacent side. Sorry about my handwriting. Adjacent. Now, how is it actually helpful? This means that sine theta is equal to, well, the magnitude of v hat y, which is just vy, and cosine theta is magnitude of v hat x, which is just vx. This means that we can construct any unit vector by the length of one side multiplied by I, so that's vx I. This is because this one corresponds to this red vector. That's because you want to scale I down, right? And this v sub x is a scalar. You're trying to scale I down to some value. And notice that the maximum value of sine and cosines, they're 1, right? They're usually less than 1. Meaning that this v sub x is less than 1, it will scale I down. It will never scale I up. Then you add it with v sub y, j, right? And then you substitute sine and cosine, meaning that any unit vector can be written as cosine theta I plus sine theta j, right? This is how you write any unit vector based on only three things. The angle, which you have, and then you have the two unit vectors, which you should know is the I hat is the one pointing towards the positive x direction, and j hat is the one pointing towards the positive y direction. Now we have this formula up here, and then we replaced v hat with this one, meaning that we will end up with any vector v, doesn't have to be unit vector, can be written as the magnitude of v multiplied by cosine theta I plus sine theta j. Right? I know this looks complicated, but it will actually help us solve problems. Rewriting that, distributing that, we have, this is the big thing today. How do we interpret this? Let's see. You want to create a vector that doesn't have to be a unit vector, okay? By splitting them into two separate vectors. You have this vector and you have this vector right here. Those are vectors because I hat is a vector, right? And j hat is a vector, and those are all scalars. Let me just undo all of it right here. So that means this vector is constructed using the by the sum of two other vectors. Now, what are those two other vectors? Those two other vectors are basically I hat scaled upwards. Now, even though cosine theta was scaled down, magnitude will usually scale up because usually, I'm talking in general, magnitude is bigger than 1. Of course, it can be less than, okay? But the ones that we'll deal with probably will be greater than 1. It doesn't really matter. But anyways, the main idea is you scale I up or down, and then you scale j up or down, and then you add them together to create any vector that you want. Usually in questions, they will format a vector like this. They will say that a vector v is equal to, for example, 3i plus 4j. Now this, even though, yeah, it kind of looks similar to the formula we have, we lose information though, because the how do I say it? The scalar of I is composed by the magnitude of v and the angle, right? Same for j. However, you only have a number here. You only have 3 and 4. That means 3 must be equal to magnitude times cosine theta, and 4 must be magnitude times sine theta. Now, there are ways to find the magnitude using those two numbers. It's the next section actually. And there are ways to find the angle, of course, but just looking at it, it's not obvious at first glance. Anyways, that should wrap up everything for this section. So if you have any questions, please leave it in the comment section down below. And as always, easy.